So we're still in 11.3 on the integral test. So I'm gonna sum up some things for you that we discussed last time. So I ended by talking about a p-series, and it's a series that looks like, the terms look like 1 over n to the p, and we said when this converged and when it diverged. So do you remember when it converges?
If p is less than 0.
If p less than 0, I think it was greater than 1, right? It was at the very last thing, I think. I wrote a statement that says if p is greater than 1, it converges, and it's going to diverge if p is less than or equal to 1. I'm pretty sure that's where we ended last time. Okay. So we can use this general rule and apply it to some series now, where I've established values of p. So let's consider this first series, 1 over n cubed. What's my power? What's p? 3? Do we all agree it's 3? So I've identified that this is a p-series, and I've said what the value of p is, so now you should be able to tell me, does the series converge or diverge? It converges, right? If I get a number bigger than 1, it converges. So p is greater than 1, so now I know that this series converges. Okay. Let's look at another example. Let's say I look at 1 over n to the 1/3. Again, we see that this is 1 over n to a power, so I know that this is a p-series. What's my value for p here? 1/3. Yep, it's less than 1, and so now I know that this series diverges. Okay? So you identify your series in the problem. I've identified it as a p-series. So to answer the question whether or not this series converges or diverges, you identify the value of p. If it's bigger than 1, it's converging. If it's less than or equal to 1, it diverges. Okay? Any questions about that?
It's only for 1 over n.
Yeah, so that's a good point to make. A lot of times I see with p-series, you want to think that other things are p-series. It's only if it's 1 over n to a power. So if you have anything else, it's no longer a p-series. So for example, maybe I'll put note here. Note, if we have a series that looks like n equals 1 to infinity, 1 over n squared plus 1, this is not a p-series. Okay? So it has to look exactly like the form that I wrote at the very beginning. It has to look like 1 over n to the p. If it doesn't look exactly like that with a value of p chosen, then it's not a p-series.
So
Okay.
even if like the top number says like 2 or 3, then it will be the same?
If the top number says,
It's a numerator.
Top number, yeah, is a 3 over n cubed?
if it's a 3, you can pull the constant out. So it's okay if you have a constant there. But if you, so yeah, if you have, I get what you're saying now. If you have something that looks like 3 over n squared, We talked about how constants, you can pull them out in front of sums of these series. So this is still going to be a p-series, yes. But any other change, if you have something added to the numerator or added to the denominator, or yeah, it has to, you have to be able to simplify it so it looks just like 1 over n to a power. Okay. Other questions?
As long as it's not like polynomials, then should be good.
As long as, the thing to not confuse here is don't think that a rational expression, like a polynomial over polynomial, means it's a p-series. That's not true in general. Okay.